Good morning. Okay, so I thought I would just be nifty and just put this on the screen for you to see. So we're going to go ahead and start chapter 16. Now we're going to finish this chapter this week. It doesn't show on the schedule that it shows that you'll take test 3 in a different week, but we're gonna get this done this week. So chapter 16 is gonna be done this week, and we're gonna take a test and be done with this part, and then we'll finish it. We're almost done with the book actually, and then we'll get to start a new book. But anyway, okay, so let's look on at chapter 16. That would be, I guess, on page 315 in your book. Okay, this week we're gonna be talking about exponents. So you may or may not be familiar with exponents. So let's go ahead and look at section 16.1. Now, we discussed in the last chapter how to express area in what we call square units. Remember doing that. A square foot is a square 1 foot long and 1 foot wide. 9 square feet represents 9 of these square feet. And right there in the middle of the page, it kind of shows you there's 1 square foot. That means it's 1 foot. It's a square, and it's 1 foot on all sides. Okay? Now, when you add 3 of those up and 3 of those across, and you make another square out of all those squares, you then have 9 square feet. Okay? It's time now to take a look at a notation that we can use to help us express these square units more concisely. All right, so often in math, we deal with multiplying a number by itself multiple times. For example, when you find area of a square, we're multiplying a number by itself. Example, when you were finding the area of that square right there up in the middle of the page, the one that was 3 feet down and 3 feet across, 3 square feet down and 3 square feet across, you were finding the area, so you multiplied 3 times 3, okay? Now, exponents are a notation to, I have no idea what that word means. I think it means exactly, succinctly write and work with numbers multiplied by themselves. So in exponential notation, we use a superscript number to show how many times a number could be multiplied by itself. Okay, so turn the page. So using an exponent, 3 times 3 could be written 3 with a little tiny 2. The superscript 2 tells us to multiply 3 2 times, not 3 times 2, 3 times 3. You take that number and multiply it that many times. And by reading it, you would say 3 squared is what you'd say on that one. Okay? All right, I just dropped coffee on my book. Just FYI. Oh, well, I guess I need to leave my mark somewhere, don't I? All right, so you're going to read 3 with a little 2 up there. You're going to read that 3 squared and refer to finding the answer as squaring the number. After all, that's how we'd find the area of square 3 with sides 3 units long. Okay, so you don't have to stop, though, at squaring a number. I'm going to take this down because I'm probably fixing to have to be writing up here. All right, so exponents can be used to represent any repeated multiplication. Notice in this chart, now in the middle of page 316, notice in the chart we wrote the number that needs multiplied. Then we wrote a superscript number indicating the number of times the number should be multiplied. So for instance, if you see the notation, it goes down the side, you have 2 with a superscript of 2. It means 2 times 2, and you read it 2 to the 2nd power or 2 squared, either way. Now we're going to learn what the word power means in just a minute. The one under that is 2 with a 3. That means 2 times 2 times 2, and that we say would be 2 to the 3rd or 2 cubed. Cubing a number is when you use 3. We'll learn about that later. And then you have 2 with a 4. It's 2 times 2 times 2 times 2. That's 2 to the 4th, and so on. And you can go as long and as much as you want. Now, look at the gray box that says term time. As you continue in math, you may hear people talking about raising a number to a power. A power is another name for an exponent. 3 raised to the 4th power is another way of reading 3 to the 4th, or 3 times 3 times 3 times 3. You can just say 3 to the 4th power, or just 3 to the 4th. Okay, does that make sense? All right, let's move on to applying exponents to units. When we find an area, we're multiplying a unit by another unit. So let's say we have I don't know if you can hear my roosters in the background, but I have my window open and I'm right beside it and my roosters are crowing. Okay, so we find area. We're multiplying a unit by another unit. So 4 feet by 5 feet equals 20 square feet. 3 inches times 6 inches would equal 18 square inches. Now that we have a basic understanding of exponents, we can use them to express square units more simply. So if you have, I'm not going to use this right now, but if you have, this is at the bottom of 316, if you have 4 feet times 5 feet, that equals 20 square feet. Now that would be like saying we had this, and we're just going to say it has 4 square feet, okay? These are not going to be equal. These are supposed to be squares, but they don't really look like squares. Okay, and then, yeah, that's not even right, but just say these are all squares. I can't do it very evenly, but you have 4 square feet. These are squares, and they're 1 foot on all sides, so there's 4 of those here. And here you have 5. Just pretend these are perfect squares, and they're each 1 foot by 1 foot, and you have 5 of these. Okay, so to find the area of this whole area, you would multiply 4 feet times 5 feet. Now, since we squared it, these were all squares, you just multiply, but your answer then, we were writing 20, and then we were writing SQ feet, square feet, but just to write it more easily, you just can write the abbreviation for the unit and put the subscript at the top showing that it was squared. Okay, 2 always refers to squared. All right, or you could do 3 inches times 6 inches would equal 18 square inches is how you would say that. Look at the very bottom of 316. As with numbers, an exponent to the right of a unit, such as inches squared, represents how many times the unit was multiplied by itself. When you multiply inches by itself 2 times, we get square inches. So look at the very top of 317. So you have a big square up there. It's 1 inch by 1 inch. Okay, not really, but it is just showing you that. So in order to get the answer, the area to that, you would multiply that, and it equals 1 square inch. Because you are squaring, we're using squares to represent the area, and we're doing it along this side and along that side, so we're saying square inches. So using an exponent instead of words to represent square units will help you more easily work with them, as we'll see later on. So we're just saying how using, instead of saying square feet or inches or whatever, we're doing this. Okay? All right. Let's look in the middle of 317. Applying exponents to numbers and units. In 20 square feet and 18 square inches, the exponent applies only to the units, feet and inches, not in the numbers 20 and 18. If you wanted to show that 20 feet needed to be squared, that is 20 feet times 20 feet, you would need to use parentheses. It shows you right there on 317. The exponent applies to whatever is directly to its left, whether it's a number, a unit, or grouping inside parentheses. For example, we'd find the area of a square 3 feet by 3 feet by finding 3 feet times 3 feet, which would be simplified to 3 feet squared, or 3 squared feet. Notice you put parentheses around the 3 feet. The parentheses make it clear that 3 feet needs to be multiplied by 3 feet Without the parentheses, 3 feet squared just means 3 square feet. Whereas 3 feet squared, or 3 square feet with parentheses, represents 3 feet times 3 feet, or 9 feet squared. It's kind of confusing. So look at the little box. You have, if you just have without parentheses 3 square feet, that means you just have 3 square feet. Okay? But then if you have 3 square feet with parentheses around it, that actually means that you have 3 feet times 3 feet, which equals 9 feet squared, or square feet. You can say feet squared or square feet, doesn't matter. Okay? You can also use exponents to simplify formulas. For example, rather than looking at the area of a square as the area equaling the side times the side, remember area equals S times S, you could just look at the area equaling the side and just do A equals S squared. So the area of a square, we were saying area equals side times side, or A equals S times S. But now we can just say A equals S squared, because that's what the area of a square is. It's just the side times itself. The exponent is just a shorthand way of representing the multiplication of a side by itself. All right, let's look at the next page, 318. Now, remember back order of operations? PEMDAS. Now, remember that second, if you do this, remember parentheses first. Remember this E for exponents? We haven't used that just yet. But notice exponents comes after parentheses. Sometimes exponents will show up within a problem, such as if we need 20 square feet of carpet for an area, plus we want to carpet an 8-foot square room. Here we have 20 square feet plus an 8 feet squared room. So what do we solve first? Well, we know we need to multiply before adding, and exponents are really just a way of representing multiplication. We could rewrite the exponent as multiplication, so there they've rewritten it. 20 square feet plus 8 feet times 8 feet. Okay, that's, now notice up at that top where they have that equation, the first equation, 20 square feet without parentheses, plus 8 square feet, or 8 feet squared. Okay, so 8 feet squared might be an easier way of saying that. 8 feet squared. Okay, that means it's 8 feet times 8 feet. So they just rewrote it. Okay, they didn't have to rewrite 20 square feet because that's already what it is. Okay, and now it's clear what you have to do. You have to multiply first. You have to do the multiplication first, which is why exponents come first. So the order of operations are listed here for review in that gray box. Notice that exponents are listed right after parentheses. This makes sense since we'd need to multiply the exponents before we can complete the next step, which is multiplication. So there's your order of operations written in the gray box. Now on the keeping perspective, it says exponents are a useful way of expressing repeated multiplication. As you focus on learning this part of the mathematical language, so to speak, don't forget why you're learning it. So you'll be able to describe, understand, and work with real-life problems. The worksheets in the student workbook for this chapter will give you some simple examples of exponents in action. Know that there are thousands of applications too. The more we learn about math and apply it, the more we're going to find ourselves working with exponents, and they are very helpful. Okay, with that being said, let's look at our worksheet then. It's worksheet 16.1. So let's see, we can use our calculator on the back, just on number 3, so you can have your have it close by. All right, so now it says in the gray box at the very top of 16.1, it says now that we've covered exponents, be sure to use exponents to express square units. So from here on out, anytime we're using area, we're trying to find the area of something, make sure we always express those units with the little square at the top. All right, look at number 1, exponent time. Use exponents to express these multiplications more simply. Okay, so look at A. How many 8s are there? 1, 2, 3, 4, 5. There's 12. So your answer on 1A then would be 8 to the 12th power. That's what that means. Okay? All right, look at B. 50 and 6/10 times 50 and 6/10 times 50 and 6/10. Hint, you can rewrite decimals as exponents too. So what do you think this is going to be? To the third. 50 and 6/10 to the third is what that's going to be. All right, let me take a look here and see what it is. Okay, let's do C. So how many 3's are there? I counted 11 of them, so it'd be 3 to the 11th power. And D, 1/4 times 1/4 times 1/4 times 1. It says repeated multiplication of fractions can be written using exponents as well. Just put the fraction inside parentheses to avoid confusion. So that means your answer on D with the fractions then would be, let me make sure I find this right thing on here just to make sure. Okay, so it'd be 1/4, and I'm assuming you put this in parentheses. How many times do you have 1/4? 4 times. So that's how you'd write your fraction with an exponent. Okay, so then we'll move on to E. -4 times -4, that would be 1, 2, 3, 4, 5, 6 times. Now hint, when using exponents to show repeated multiplications of a negative number, you have to put parentheses around the negative number to make it clear you mean the negative number is multiplied that many times, and not just that you want the opposite of the results. Example, -2 times -2 would equal -2 in parentheses squared, which equals 4. Whereas -2 squared without parentheses means the opposite of 2 squared, or -4. So we have to be careful with that. So if we are doing a negative number and we want that negative number squared, then we have to put it in parentheses. 1, 2, 3, 4, 5. There's 6 of them. So it would be this. Make sense? All right, look at F and G. All right, they just want you to write the units squared. So centimeters squared, there's 2 of them. And then inches squared. Okay? All right. Now, on number 2, it says more exponents. Rewrite these as repeated multiplications and then solve those. All right, so on A, you're going to multiply 4 times 4 times 4. So write that out just like that and put your answer. And then on B, just so we're not confused, remember we always put fractions in parentheses, and that's 2 times. So on B, it's basically this. Remember how we multiply fractions? Just multiply across and simplify. Okay? All right. Then let's see. On C, that's 2/10 times 2/10 times 2/10 times 2/10. All right, you're going to multiply that. Now on D, now since the negative number has parentheses around it, that means you're going to multiply -10 5 times. And remember, this is one of those negative, positive, negative, positive, negative, positive. You have to kind of count, which way it's going to be and put your answer on that. Okay, so if you want to pause it and go ahead and finish that, you can, and then turn it back on. I'll help you with number 3 on the back. Okay, so if you did all that, let's look at number 3 on the back. All right, so this is applying exponents to geometry. So on A, it says to represent an area of 87 square miles using an exponent to show that the miles are squared. All right, so what you're going to do then is basically your answer is going to be 87. And then you need to put your unit and square it. That's all it's wanting you to put. Okay? Representing an area of 87 square miles. Let's say we have this big, pasture land or whatever. And it just wants you to represent the units that it's measured in. It's 87 square miles. That's the total of this area, okay? That's all it wanted you to do, is just to write it that way. All right, then. Okay. Then let's look at B. Find the area of the parallelogram below. Okay, let's see if we can remember the formula for a parallelogram. All right, remember it is area equals, I do believe it was, I don't have it in front of me, isn't it base times, was it areas base times height? Or no, that's a triangle. I think it is. No? What was that? Let me look in the back of my book. Is it back here? I think I put it in here. Yeah, let's look back here. I do not remember formula for a parallelogram. Oh, that's right. Base times height. That's correct. I wasn't all the way going crazy. Okay, so base times height. Okay, so then what we're going to do is we're going to go ahead and put this in there. Okay, the base is 16 inches. And the height is 12 inches. Remember, it's the one that goes straight up. Okay? So what you're going to do, I'm not going to do the calculations, but you're going to multiply 16 times 12. Now you need to remember, it's area. Area is always squared. So whatever, make sure you put your answer, and it will be square inches would be your answer. Don't forget that. Okay? Now you can pause it while you finish that, and we'll look at C. All right, on C it says find the area in yards of a square with 120 foot sides. Hint, convert to yards before finding your area. Yay, yay. See if we can do this one then. So we find the area in yards of a square with 120 foot sides. Okay, I have to see things. Okay, so this is a square, so it has 120 foot sides on all sides. This always means it's the same on all sides. Okay, all right. Actually, foot is FT, period. All right, so what we need to do then is to convert 120. Let's see if we can remember how to do this. Conversions. Okay, we need to do 120 feet times. Now we want yards, right? So that means we need to write the ratio to feet to yards, but we want yards, so we have to put yards up here. So 1 yard is the same as 1 yard is 3 feet. That's our ratio, correct? Okay. Now cancel out these things. All right, so we're left with 120 over 3, which equals, and we're left with yards. 3 goes into 120. What is that, 40? Yeah, 40 times. So we're left with 40 yards. Okay, remember how we did that? We converted that. All right, so we've converted to yards. So now it wants us to find the area in yards. So this is actually 40 yards. So we are finding, this is our next step, finding the area of a square. Okay, remember the formula for area of a square is this. Remember we said it was side times side. But since now we've learned exponents, it's just area equals S squared. So let's fill in our numbers. Okay, A equals, it's 40 squared. Okay, so the area is going to equal, you figure out what this would be and write your unit correctly. Okay, go ahead and figure that out. Pause it while you figure that out. Okay, you got it? All right, this should have been your answer. And it would be square yards. Well, that's supposed to be a 2, but this would be your final answer. Okay? All right, I hope you got that right. All right, so on number 4, it's just order of operations. So go ahead, you should be able to do that just well. And then 5, and of course 6, you don't have to do that unless you just want to do your flashcards. So anyway, I'm not going to grade it. I'd like to see it though whenever you're done, whenever you hand it in. So anyway, that would be all for today.